Oh, right, everyone. Finally, recapping for the deck Technics RS-M95 is complete. That was the last bunch of capacitors I replaced. Now it's time to assemble and start tuning. See you in a moment. All right, assembled. All boards are in place, and guys, you know what? Forget everything I told you about, like soft, deep sound, like same as A9, same as Denon. As soon as I replaced all capacitors in this deck, it became crystal clear. It has all range of frequencies, and sound is very close to the decks from 80s and 90s. All right, it's really Technics sound now, not the soft. So I believe the decks I've been restoring, like the Pioneer A9 and the non-M44, have the same issue with old capacitors which require replacement. I check it up different modes. I check it Dolby, without Dolby. Believe me, it's still not that soft as it was. It's way more detailed. There are so many details now. Wow. All right. I hope I will be able to make a video for you with a sound demo, so you will be enjoying the same as I do. All right. So now when everything works, it's time to start assembling this body, and then we will start tuning. See you soon. Okay, guys. A couple more observations. All right. So I believe it's currently show the RMS level or like view level, right? And I want to see how to switch it to peak indicator. This button. Now we have good levels. Because I was installing my Dolby level tape, it shows Dolby, but this tape, exactly this, like for example, it plays +4, +5 decibel on all decks, and here it just shows +2 maybe. Alright, even if Dolby level is correct. And now everything is tuned for playback, and it plays well Dolby factory tape with Dolby B, and like you see, I can remove Dolby and high frequencies are over the roof, and now everything is fine. Really, head appeared to be in a good shape, and like all issues were from the old dried capacitors. Okay, and as I told earlier with the sound, it's completely changed. From soft cotton, it became very detailed, very nice. One of the best decks, like from the resolution perspective. Really interesting how everything changed. All right, it has quick tape transfer. Oh, it's pause. Sorry. Fast forward, rewind, play back. Everything works. Okay. So next, I will check that it records. I believe there is no any additional ports on below, so I can assemble bottom, I can assemble front, and we will be tuning it from the top. See you soon. Okay guys, I'm assembling the front and bottom. So that's a Dolby, you see, and Dolby leads and Dolby symbol on display lead together. All right, that's a counter. So we have memory 1, memory 2, stop, play, clear. All right. Memory clear, memory. All right, memory where is reset. Counter 0. Come on. I'm puzzled. reset, clear. So it will be cleared when clear. And it sets memory as soon as it clears. Okay. That's how it works. All right. And that's how it plays. Nice and beautiful. Okay. Famous dimmed glass display, like you see, has all Technics the same color. It's not white, it's kind of warm white, very warm white. I observed it on multiple Technics decks. That's their way to make indicators. Alright, so peak, and this one is hold. I cannot see without my good glasses, sorry. Yes, and peak hold. You see, it holds it forever, and when I remove it, it's jumping. Okay. Then it would be easy to check levels and set up recording levels and so on. Good. So next, this knob was bigger, so probably need to switch these guys. Come on. Go back here. And you're the biggest one, should go here. Okay. And for the calibration levels, you need to use screwdriver. So there's no way to get there without screwdriver. All right. Let me prepare my service manual and we will start tuning recording levels and everything else. See you soon. All right. I was tested different factory tapes, my custom recorded tapes, and it appears that when I switch to normal, all tapes play perfectly well and high frequencies are enough and are there. As soon as I switch to chrome or metal, it's like reduces high frequencies deeper than like I would expect to. All right, so I would probably also check this kite to make sure that it will work properly. Everything else, like I'm just like I can't stop listening. Really great deck. Probably not the same good as like latest Sony, like from 1990s, considering dynamic range, but frequency response is pretty good. All right. So it's like reminds me like Technics B965. So some like pretty similar sounding now, like very resolving, like lots of details, good highs. There is a bass, and don't get me wrong, like bass is good, but I still feel like dynamic range is a little bit compressed comparing to the best decks I have. So probably I'm just like used it to super good sound. I don't know, like, but that one is very good. You wouldn't be disappointed, specifically after replacing all capacitors. All right, see you soon. All right, everyone, and I continue tuning, and currently I'm tuning frequency response, and I'm tuning on the chrome tape to make sure that it will be fine. And as you see, from 400 Hz to 15 kHz, there is no drop, and it's two ports here, VR1 and VR2. All right, now I would be able like to listen the recorded tape with type 4 I have, and check if it's normalized now. Let me check. Okay, I can confirm that it's now plays really nice. All frequencies are perfectly matched. Now let me test type 1 tapes and see if there are any deviations. Okay, I'm now testing this type 1 tape and Dolby B system, and I can hear perfectly well all frequencies. So Dolby works well and so on. Good. Playback has been tuned. Now I will start checking up the rest of the parameters for Dolby and for recording. All right. I'm adjusting bias leak, and it's pretty convenient done in this deck. So you see I can connect to the channel, then use a screwdriver to work with the coil and measure like here the get minimum value. So I technically can get like even higher like that. All right, and now it's left channel, so I'm using left coil. See, it goes up, so I reverse direction. I need to find the minimum value. Okay, goes up again. So here about the minimum value was the coil, and then we tune the second coil the same way, and it's super convenient to work with this deck. You see all adjustment points on top right here and here and here for this indicator board. All right, couple points here on the side, but we see the holes and they like have it marked: chrome, metal, I believe normal tape. I don't see well. EX, MX. So I would need to read more. Record equalization, left and right channel. So we have 4 coils for 4 different tape types here: metal, chrome, I believe ferrochrome, and normal. Right? Yeah. See, normal. Yeah. This is ferrochrome, chrome on top, and metal. All right, let me continue tuning and assessing. So far it plays really well, and I'm really enjoying because this restoration will really gets pretty good. Here guys, this pretty interesting step is to correct waveform. All right, so if it will not be distorted, should be symmetrical. And I'm just connected to the first point, and you see it's distorted, so I need to use VR 853. Okay, 851 and 852. All right, I see bias current and very sick. Let me find those VRs and then get you back soon. And what I'm observing, so those VRs are really replaced with permanent resistors. So I need to install them because I need to correct these waveforms. See you soon. All right, I installed these resistors as pots, like 20 kilo ohms, and I tried to adjust them. And what I observe, that we cannot do it fully symmetrical. It can be like that, or that's the indicator. So we should avoid these lower pikes. So we should set it so it would not have it. Let me go back to the service here. But I cannot go them symmetrical. All right, so you see they recommend to remove these bumps. Should not be here. They should be more symmetrical, like I believe like 40 by 60%. So we may try to adjust a little bit. I'm not sure how it will affect. It will be like that, right? And the second channel. So it should make more symmetrical waveform. But you see it's affect amplitude, so I'm not sure what will become with amplitude. All right, so it's 2 shoulders, so that's where like 1 transistor opens, and then like the other channel is other transistor opens. So they work in the opposite phase, making sinusoidal signal of this bias generator. Alright, so we made it as close to like 50 to 50% as possible on both channels. Alright, probably even can do a little bit more here, like that. Right, so I'm watching the lower level, make them like 50%, like right here, so they make even. So this means one transistor opens, another open, one open, other open. So it will be like that. And same here, you see, same intervals. All right. Should be good now. Continue tuning. All right, and with the next step, I was able to set the wave adjusting this coil T852. All right, so you see tops are now symmetrical, and one channel and the other channel, two transistors in the generator. All right, adjusted. Moving on. All right, and next up, bias current adjustment, and I'm measuring on the points for left and right channels, and we will be adjusting these two ports with metal heads, and like we need to get 1 milliampere, right? That we need to read voltage from VTBM and divide by 10 ohm, and I have 28 millivolts. Divided by 10, it's 2.8 milliampere, and we need just 1 milliampere. Let me see. Oh, it's ferrum chrome, metal position, 2.2 milliampere. All right, so we need to start with normal. With normal, it's exactly 1 milliampere. Good. On one channel, and connecting. Sorry, I can't see without my glasses. I need double glasses now, really. So getting so bad. And the other channel. So a little bit more the other channel. Exactly 1 milliampere now. See, second scale from the top. 1 milliampere. And this channel a little bit less. So that's important to set to be even between left and right channel. All right, done. Because this will affect record phase, as we already learned it on other decks. All right, that's how you can do it. Moving on. All right, so we have 4 values. Standard value for normal tape, ferrum chrome, chrome, and metal. So we set standard here in normal position, then we switch to the ferrum chrome, set with BR22, then chrome position here, and with metal position. And currently on metal we have 2.2 milliamperes. So good. Continue tuning. So next, set arise current. So we need install metal tape, set metal position, record pause, and achieve 95 milliampere. So that's the measurement point, and that's the adjustment resistor. I didn't touch yet. It should be 95, and I see like below the 90. All right, so we need to increase the rise current. to, I cannot get 95. I can get less, but that's maximum. It's 90. Okay, almost 90. All right, moving on. And next step is adjust record level and pause here. One channel, another channel. Two ports right here. All right, the switch and source tape. We should have the same values. Good. See, same as the indicator. So this level is 0.65 volts, right? Good. Continue tuning. And here, guys, I'm just completed calibration for indicator. It works mostly well, except like minus 40 decibel was a little bit jittery on the right channel, but it's understandable. Signal level is very low. Everything else works still fine. Okay, moving on. So that's the zero level in this place. And if I make minus 20, all right, we have minus 20. You see that's sporadic behavior a little bit on the right channel. I don't know, maybe it's no cover. It started recently with the low levels. Maybe I need to stop recording now. See, something gets wrong. Oh my gosh. With high levels it works better. With lower levels there is some like, hey, really didn't expect that. High levels works well, lower levels something wrong is happening. Okay, let me see. All right, everyone. I thought it will take forever, but it took like about 3 hours. So what's really happening? So I had to find an issue. Let me show you on schematic. So it was OpAmp, but those are specific OpAmps with Toshiba 75 or 6, I believe. You see this one. It's IC 908 and left channel 907, two of them. That's a single OpAmp in the 8-pin deep corpus. Pin deep, like 8-pin deep body, alright? And I look at the parameters and I found that I have similar Texas Instruments and E5534, right? So that have the similar layout and similar capability to adjust frequency response with external capacitor, all right? So this I see like they degraded and started to self-resonate, right? That was the root cause. I was like detaching piece by piece. Like I found like that it's between 908 and 906 with oscilloscope. So there is oscillation. I detached these transistors, removed them. I detached diode from pin 6. It still generates. And only when I detach it from pin 2, self-generation stopped. All right, so that's where like my idea was that this IC is bad. I found replacement, I replaced it, and now it works. So it's 0 decibel, right? Now I will set up minus 20 decibel, right? And now I will set up minus 42. Minus 42, and it should not lead this minus 40. And as soon as we get by 2 decibel, it starts it to lead. One more, you see, it's not even between two channels, but it's currently at minus 40, 41 decibel, right? And we see it started to lead, right? So indicator is calibrated properly, and that's a good sign. And zero level is 650 millivolts on this deck, right? So for you to know, and it should look like that, 650 millivolts. All right, I thought it would be quicker. We'll turn off my desoldering iron. It was time consuming to find and fix it. Now let's play the tape from the beginning. It on the empty tape with no signal, it was jumping, and now there is nothing jumps, as you may see. And when music will start, we will see perfect, nice bars. Whew. That's a lot. Now switch to the peak mode, works, and peak hold works as well. Alright, that's my test tape. I was testing it on different decks. I don't recap what was recorded here. Both modes work, peak mode and regular view mode. All right, good. Whew. So the last part left is to validate Dolby and validate recording. We calibrated already using manual, so the thing would be to validate that it records well on all frequencies. And that would be it. See you soon. Well, guys, I'm not sure on what tapes it was supposed to be tuned on the factory and using the service manual, but even on the maximum bias, I barely can achieve linear response. So you see, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's, wow. It's modern tape, it's brand new tape, and like bias is on maximum. So it has lots of spare. That's we would need to check on other tape types. So there is no adjustment for the bias except these two ports which we set for 1 milliampere and like these tape types. I probably will reset it to make sure that it will be even bigger, like it was like 2.2, right? Or maybe even 2.7, like, but make sure that it would be really linear in the middle on the modern tapes. So let me do it when I see soon. All right. That's what I come up with the modern tapes, right? So I probably need to adjust the bias on the board, but I believe for metal I'm already set on maximum. So that's how much I have to add from the middle to compensate for TDK MA, right? That's how much I need to reduce for the chrome. So technically I may adjust chrome a little bit, and a little bit I adding out for the type 1, right? So not bad, but let me see if I can do better for chrome. Let's see first for metal how much I can add. Okay, doesn't change much after we reach this position. All right, so but on the front I can reduce. It's almost not changing on metal tape, but now it's flat. All right, now let's see type 2. Again, type 2 record. Bias didn't affect on type 4 because frequency was low. Let's try again. Let me switch to the 10 kilohertz. Yeah, that's now. This now affects type 4, please. 400 years. Okay, now in the middle, and I can adjust a little bit more. Done. So now it will be in the middle for the type 4. So see how well it records. Source, tape. And we have the same jump on the 400 gears. So source, tape. So we need to tune bias to be linear, right? For the tape, for levels, we have 2 more ports here. All right. Now, let's see type 2. Type 2. 400. 10 kilohertz. Yeah, tape is not very good. So let me see if I will put in the middle. Now I can adjust right here. Okay, this I don't like this tape. Why it does it? Let's change the tape. Let's use Maxell. That's much better. Now we have levels. So you see levels in the middle, and we have everything playing fine. So source, tape. But there is no difference in the amplitude between 400 gears and 10 kilohertz. Okay. Good, so in the middle. The last one, that's type 1. So 415. Probably we'll adjust a little bit left, right. Just a little bit. Oops, too much. Done. So, and it's perfect in this position. Okay, so tuned. Now we can check Dolby. It keeps levels with Dolby and without Dolby. 10 kilohertz is the same. Good. Tuned. Now let's see calibration mode. 400 hertz. Source, tape. There should be adjustment for the generator. And 15 kilohertz and 400 hertz together to adjust the bias. See, I may adjust bias as it, so they need to be the same. And on 400 levels. Okay, good. I need to adjust generator, see? Let me find this adjustment. All right, adjusted. So the final adjustment is here, VR3 for the level. So like 400 Hz and together 410 kilohertz. See, 400 Hz left, right, and now one channel plays 400 Hz, another 10 kilohertz. Pretty interesting. I had to put bias in this position because it tries to tune up at 0 VU level. It's -4 on the DIN scale. All right, this deck cannot record type 1. It's the same quality. So I believe that would be the more appropriate position. So it will be showing a little bit of degradation, then it will be the same. Because at 0 level, yeah, I can put it like equal, but imagine it at 0 VU level. All right, done. Complete, tested, tuned, works. Now I have to assemble the rest of the body. I need to check these level ports. And let's see how it will adjust levels. Yeah, goes, and right channel. So, good, full calibration on this deck, and that's the signal which I'm recording. So we see how much more high frequencies it will have if you will calibrate not on -20 but on 0 VU level. That's on -20, so that's adjusted, and calibration says no, adjust. So I'm adjusting. What happened? Source. Aha, we need to make sure the source tape will be the same. So, source tape. Source tape. And one less. Like that. Source tape. Source tape. Now it will record properly. So source 10 kilohertz and recorded 10 kilohertz. Fine. Solved. Now it's calibrates properly. So the level for 10 kilohertz embedded generator don't adjust separately. So they're just one port. So when you will be calibrating, the thing you need to do is to watch source and tape, so levels will be the same. Okay, then it will be recording pretty well. Now you know. Let me assemble, and I meet you right there. Hello everyone, and now I'm testing recording capabilities of this deck, and I'm testing on the pretty nice sound, and it records almost without differences, and with Dolby it records pretty well either. So I'm happy that it works. That would be the final video, and thanks for being with me. It was a long restoration. That's the amount of parts which has been replaced. All capacitors, electrolytical, and 2 ICs. Alright, and 2 tantalum capacitors. So I'm glad that it came up that good. It could be worse than that. So I hope owner will be happy. Bear with me. Thank you. Bye bye.